Okay, guys, welcome back. Let's check. Number one, you have homework to submit. If I am correct, or you submit yesterday, due date is today, I think, right? So you still have until midnight. So just do not forget to submit. The homework kind of easy, it should be. I received some questions and I just would like to clarify. Basically, it is okay for you to take the source code that we have been reviewing. It's exactly the same, the code that is in my slides. And the only thing that I am asking you to do is to play with the parameters. So the program is there, it's not a huge programming assignment. It's basically for you to change some numbers and some classes if you use a different updater, and nothing hard, right? I am asking you to create at least one good solution. I think I almost give you the good solution, or is something that you can easily figure out. The good solution is obviously going to be probabilistic. So the good solution is going to include this likelihood and softmax at the end. Other than that, you can play with the parameters and you're going to find a good thing. The other thing that is going to be important is the number of epochs, how many times you pass over the data. Obviously, a bad solution is going to be use one pass, one epoch. So those two things are going to be kind of the key in your submission, in your homework. Other than that, I am asking you for other two. There is no particular requirement for the other two. I know that I mentioned a bad one and a medium one. I am asking you to play with the parameters and play at least 3 times. And one of those 3 times should be something good. Something good, remember, above 95% or the error 0.05. That is basically what I am asking you. You are going to find things that are interesting. Someone asked me like, hey, I can put this error function, the square error, and it's going to look very good. Yeah, it's going to look very good, but then when you move that model to the real world, it's not going to work really well. The problem is not with the numbers. The problem is you are using something to calculate the error in something that is probabilistic, that the function itself is not. The model, you need to figure out, or you need to know what you are doing and what are the best solution for what you are doing. If not, your testing data set could work, but that do not guarantee other data. And that is going to be your next homework, right? So for now, I am just asking you for something that look good in terms of the metrics that we review, the error or the prediction. Good. So I think it's going to be easy. You do not forget to submit. This time, I am still asking you for a paper. The source code is important, but my expectation is that the source code is going to be inside of the paper. I know your paper is going to have probably 60% of similarity with others. Don't worry, we are reviewing, the TA is reviewing, so 60% doesn't mean that you're going to receive an academic integrity thing. The only thing that we're checking is your description, your explanations are yours. The source code obviously is going to be, again, most of you are going to be my code with different parameters, with each basically a lot of coincidence, right? So we're aware of that, don't worry. 3 solutions, explain your solution. That's it. It's an easy homework. Good. Next step. The homework that I am going to ask you to do today, and before asking for the homework, I am going to give you kind of a view of the things. But my next request for you working in a homework, before moving to more complex models, remember, these neural nets are fine, but really, it's like the only thing that they can identify is one picture, if the picture is or not. And I am sure that you're waiting for, what if I have a big picture and I want to identify this student and this chair and this table? I want to identify more than just one element there. We need to move to the convolutional thing. Don't worry, we're moving to that next week. But for now, and to close the topic with the net, I would like to have you doing software. And in particular, I would like to have you doing a model yourselves, not using my source code. But the most important thing is put that model inside of a piece of software. I am going to show you 2 examples just for you to know what is my approach. Your homework, to create a model. Your homework, to create an application that uses that model. The challenge, I am going to ask you to use a data set, data, that is none of the ones that I have been using. So not the iris data set, not the memes data set, something new. Something new, like what are we going to do? Well, do you remember that there are a lot of data sets online? So I am sure that you can go. I put the link in the slides, and also you have the link in my previous slide. But my goal is for you to go and explore, and it's like search for something that catches your attention. Again, nothing that you need convolutional thing, nothing that have more than one element in the picture if you're going to use images. It could be data, like comma separate values. I show you the iris for one reason. Maybe you can stuck with those kind of input. I am fine with whatever you select. Moreover, I am giving you the link for the data sets that are online. But if you are working a particular project in which you have data about something and you want to use your own data for that thing, it is also okay. In some point, I am going to ask you about if you can create a neural net to figure out if some of you is going to pass my class, but you need the data. I am going to give you that later. For now, any data set, you select the data set, you do the model, again, a simple model, and then an application. For the first time, your homework. The instructions are going to be online, but use the big picture. For the first time, the things that I am asking you to submit is source code. For the first time, what the TA is going to do is to run your programs. It's not going to be just review your paper. Now I want to run your software. My expectation is you are going to create at least 2 classes. Why? Because I am hoping that you are going to create a program, a class, for the training part, and another one, at least one, for the application that is going to use the training. Hopefully at this point, you know that do not make sense to have one program do both things, because training is not something that you're going to do every time that you run the program. Makes sense? Now, I am talking about these 2 classes, but I am sure that for the application, you're going to create some kind of model view controller, at least, like an application with several things. And therefore, probably your application is going to be more than one class. Software engineer, right? So I am expecting you to show me those skills. Probably not software design. I know for some of you, I expect a good design, identify some faces. But it's not something that I am going to grade because maybe it's not the background of everyone, but do your best, please. The only thing that I am asking you for the code, and that is something that you know, is documentation. I am asking you for Javadoc. Javadoc, basically comments for your classes and your methods. And remember, the comments, the Javadoc, is not for the programmer, but for someone that is not looking to the code. So the Javadoc are okay to be repetitive, right? And obviously, I am asking you for the Javadoc of all your methods, public methods, and all your classes. So you can explain them to me, like I can know what you are doing, what is the goal of that class. That is your goal. Now, for the first time, your homework is not going to be individual. I mean, you can work alone if you want. I am okay with that, but you can work with a team. My proposal, you can be a team of 2 or you can be a team of 3. More than 3, no more than 3. You can be 3, you can be 2, or you can work individual, up to you. Again, the idea is you're going to do programming. Again, you're going to do the training in one program. You're going to do the application. The application is going to have at least model view controller or at least model and view. So I am thinking that the minimum number of classes that you're going to submit is 3. And therefore, that is my number of maximum members in your team. Like at least everyone is going to do 1 class or something, I don't know. Software engineers, you know, and I know, 2 people doing the same class, that is not going to happen, right? I mean, we are working together. It could make sense if you have a class or a program with a lot of methods or very complex methods, but the homework that I am asking you to do is not the case. So to be honest, 2 people in 1 class, we are doing pair programming. Well, hopefully you really are doing pair programming. Anyway, up to you. The only thing is you can work in a team if you want. You are going to submit source code, Java files. We're going to compile them. We are assuming that you are using the library, deep learning for Java. That is our only assumption. If you are going to use other libraries, like you're going to do a fancy application that do plotting on charts or something, and you want to include free chart, other libraries, just let us know in one README file or some kind of document in which you tell us what libraries or what things we need to include in order to compile and run your program. Again, the goal is going to be compile and run your program. You know what? Good? Clear? Play with data that you are interested in. Have fun doing the program. And obviously submit something that you are proud to submit, like something that looks good. Now, my only thing, guys, please, academic integrity. Good news, nothing had happened here. Bad news, in my other classes, I am submitting academic integrity reports like, you know. So I do not want to do that here. Please, I am giving you the freedom to work with any data set that you want. What are the probabilities for this team and this team working in the same data set? It is not impossible, but could happen. Okay, happen, same data set. What are the possibilities of this team using as a background red color with white letters, and this team also using background in red with white letters? Hopefully you agree that the possibilities are very kind of low. I mean, same data set, okay. Red as a background, two teams. Oh, same layout, the same typo in the comments. And you can still think about it, right? So never happened. Anyway, you get the idea. Hopefully I make my case. Really, it is better if you submit something that is yours and get 50. Remember, each assignment is kind of 5, 4, 3% of your grade, depending on how many we do. So even if you get a 50, I am not asking you to just be okay with 50, but if you get half of the points, it's like 2 points or 1.5 of your grade, that is good. But if you do something crazy like academic integrity thing, it's going to be a 0. And moreover, I need to report you, and you're going to do this online class about what is academic integrity that could teach you something, but I am sure that you have other things to do. So please, your own work. Have fun with your team or yourself, whatever, and submit something good. Make sense? Okay, so the only thing that I need to show you is how to do the application, because so far, something that you know, something that we cover is how to train the models, how to train the models. One thing that I want to be sure that you can use is the last thing that we covered in the previous lecture about the listeners. Some of you asked me if it was mandatory to use the listener in the homework that you are submitting. And my answer is no, I am not asking you mandatory to show me that you know how to use the listener. However, something that I want you to be aware is the listeners are a very good tool when you are training your model. Probably the important thing here is you are checking your model in your time, in real time. When you're training, you are kind of checking what is happening with the training. It is very simple to add the listener, use one line. I already give you a source code for the class that could be the listener, so you can literally copy paste this class and this line, and automatically you have this listener that at least worst case scenario, this one is printing on the screen all the values of the error function per iteration. And these numbers maybe doesn't tell you anything, but if you just copy paste the numbers, I mean, obviously you are software engineer, so you can put this in a file, right? And then you can open the file and so on, that could be better. But worst case scenario, if you just print the numbers, what I want you to be aware is with that, you can create this kind of plot. Better even if you can load a library that plot this data in real time. But my point is, if you plot the data, when you look to this, it is very, very important that what you're looking is this line, this curve, to get flat, right? Because in the point in which that curve gets flat is the point in which the training do not make sense to continue because it's not going to improve. It's like you reach this point in which, okay, this model is, that's it. This is the best thing that I can achieve with this architecture. If the line gets flat above this 0.05, what you need to do is to change the architecture. What you need to change is the parameters. You need to move something, but continuous training is not going to help. But however, if you are here, you know that you do not need to change the parameters. What you need to do is to run more times with more data or more iteration with the data that you already have. Because there is a high possibility you are going down. There is a high possibility that you can continue improving. So that is the reason because I show you the listener. That is the reason because I show you these numbers. This point in which you read the flat part, not exactly flat, but this curve that is kind of not moving further. That is important. For the ERI data set, you reach that point, the good one, very easy. Very easy because you have a very small data set and really 4 numbers is kind of not complex to do. In fact, you do not need a neural net for that particular model, whatever. But my point is, you are going to start working with new data set. You're going to select something, even your own data. This thing can help you to notice if what you have is good in terms of the architecture, or you need to change the architecture, or you need more data, or whatever. This tool is helping you to know whether or not move forward with your model. So I am not asking you to submit the source code and put this in your submission for this homework, neither for the next one. What I am giving you is a tool that you can use to create what is important, the model, because I am asking you for a model that really makes sense. I keep asking for these models 0.05 or 99%, because in the next homework, I am going to put the model in front of a user, and you are going to be the user of your own application. And believe me, it's very disappointing when you are writing a number 3 and the computer says that that one is a number 4. Having the computer make mistakes, even though your model is perfect, for the user perspective is disappointing. And everything starts here with a model that at least reach a good point of learning curve. Makes sense? So use the listeners when you are training to figure out if you can improve more. Anyway, deploying your model. So far, the last thing that we covered in the previous lecture is that you can save your models. And if you can save your models, later you can load your models. Hopefully that is clear. What are you going to save? What are you going to load? At this point, you know, this model is just a bunch of numbers. I am going to save that. And obviously I need to save some data that is the representation of the architecture of my network. Which one? The numbers that we create, inputs, output, layers, and so on. If you store that in a header, and then you put the values for all your W's, bias, and so on, this file is your model. And this model you can open later without having to train, and without needing the data set of the data that you use for training or testing. That is not needed. Saving, hopefully very easy, very clear. Model is our model. Save is the instruction. And the only parameter that you need, a file object. And the only reason because you need a file object is because that one is going to have inside the name for the file. Hopefully you have the opportunity to play with this. It's trivial. Now, next, load the model. Load the model, something that I do not remember if I covered in the previous lecture is similar idea. You're going to load the model. Therefore, you need to create a new variable. You need to create in this new program or whatever, a variable that is going to be a multi-layer network. Hopefully it is clear that this variable is not the same as the other one that I showed you in the previous slide, right? One variable model is in one program, the program that is training, and this one is going to be in another program, even though I am using the same name, but it's good. This one, we are going to create a new object. Remember, the object at the beginning is just empty. You do not need a configuration for the new object because the configuration and all the data is going to come from this calling the method load. You load the model, The only thing that you need, again, is a file object, the file object with the same name that you use for saving. Trivial. Only one parameter here by the end. You're going to notice that for the load, you can just put the name, or you can put the name, and also you have the possibility to pass true or false in the last parameter. True or false. Something that you can ask is whether or not you want to load the data that correspond to the updater that you use. Remember that there is an updater by default, right, in the sender. But then you can change the updater for something else. The information that comes there, all the numbers that are calculated in order to do that particular process, are also in the model. Now, two things. You are loading the model to continue working with the model, continue training, improve the training, modify the model, whatever. Or you are loading the model like a static model, a model that you are going to use to predict things, but you are not going to work anymore with the training. I mean, you are not going to do back propagation you are only going to do forward propagation, but not backward propagation. In one scenario, if you want to continue training, if you want to do something with the model, if you want to use backward propagation, again, you will need the values for the data. In that scenario, your last parameter should need to be true. I want to load the model because I am going to continue working with that. Later, if we have the opportunity, is learning. I learned something in training, but I can continue learning when I interact with the user. If that is going to be the case, true, I need the updated values. It's not going to be the case for your homework. In your homework, I am asking you, train, done, static model, use the model. The model is not going to change. Doesn't matter how many errors the model do. For that scenario, you do not need the values for the data. For that scenario, you can put there false. What is the difference? Memory. Remember, values that you get from the file need to be on the memory in order to work with them. If you're not going to use the values for the updater because you're not going to change anything, you can save memory and use false there. I do not need these values. Makes sense? So you're going to notice the false in some of my examples. Now, next. We have two scenarios. We have two applications that I can show you how to work with them. Application number one for the Iris model. I am going to start with that one because it's the easy one, right? It's this data set that is comma separate values. For the comma separate values, what I want to show you is if I want to create an application like this, if you remember the value is 4 values. And basically all the values are length and width. And it is for the first element and the second element, the petals, top part, lower part. What if I want to have an application that asks me for the numbers? You can imagine that now you are measuring a new flower and you have those numbers and you want to put that in a graphical user interface, the numbers, and then you want to click calculate, calculator, and then you want to do the result. And the result should be the classification of the flower, right? For this program, we do not need the training. The training was already done. You are doing the training. The only thing that I need is in this program, load the model and use the model when the user click, calculate. Makes sense. Can you imagine the source code for this application? Can I ask you for the source code of that application? How many classes? How many lines of code? If you're thinking like one class, lines of code, 100 or less, probably we are in the correct path. Professor, really, one class? But what about the model view controller? Software design, you do not use the same rules for a building that for the house of the dog, right? So do not overcomplicate things. I am thinking in one class. Yeah, the same class is going to be the model and the view and the controller. Use like your programs in Introduction to Java. Yeah, it's trivial, right? Trivial. 100 lines of code around one class. Let's see. I could ask you to give me the source code. We can start from scratch, but I am sure that we can spend that time in the other. For this one, let's see. Two slides. This is the first one. Did you notice here something? It's the application that is going to create what I showed you before. The first thing that you're going to notice, libraries. Did you notice that I have these libraries, ND for you? Why? Professor, you told me that we are not going to train things here. We are only going to use the model that is already trained. Because you need to load the model. And therefore you need to use the class. And if you need to use the class for the model, then you need the libraries. And remember, you think that you're going to use only one class, but that class is using objects, variables from other classes. So it's not just one class, but a group of classes. And that group of classes is in packages inside of the library. And the library is separate in several modules, so several classes. Good news, you have an IDE. Your IDE probably is going to help you with all the imports. Worst case scenario, you can copy paste all the libraries that I put in my previous slides, and your IDE at least is going to help you to put in gray those that you do not need, and then you can delete it. I mean, worst case scenario, best case scenario, right? Libraries. Okay, next. I need a class. Something that I need to do for your class is to create a frame. What do I need to do in order to create a frame? The easy way. From your Java classes, extend JFrame. Do you agree with me that I need to put there extend JFrame? I am showing you the console version. I need your help to move to the graphical one. Extend JFrame, and voila, you have a nice graphical application. Second, we need a constructor, right? In the constructor, all the pictures that I showed you before, the labels, the text fields, this bottom here, the other label for the result, you know how to put that in a constructor to create a window? Hopefully, yes. Right? Okay, but the thing that you need to know is, okay, how to use the model. In the text version, main. It's another program, not the one that is training. Do you need to create a model? Do you need to load the model? You need the model that you create. You do not need the updaters. Number one, create a model. In a graphical application, that line, the number 16, should be where? Software engineering, that line, 16 in the main. This is the console version. If I ask you for the graphical one, where did you put that model, load, and so on?
That's okay.
Good. Do you think that the variable model should be global? Yes, because we're going to use that one probably in more than one method. So your decision could be global. If I ask you bonus points, I have this class that is my application. My application, what I am asking you to do is the application is going to have inheritance from JFrame. This is moving to be a graphical thing. The other thing that I am asking you is this model, this multi-layer network thing. This is a class in the library. This class is going to be connected with this one here. This is the mine. According with the description that you give me, it's a variable, should be global, and we are going to do something with that one in the constructor. What is the relationship between these two guys? Hopefully you remember that thing. Having bonus points is composition or aggregation? Should be a global variable, so the diamond. is going to be or can be null or not? The model. We're going to load the model in the constructor, right? So it can be null, the model.
No.
Hope you agree with me. If the model is null, there is no reason for having this application, because the only reason for the application is to apply the model. The only reason for the application is to calculate what flower is this, giving the parameters. This is what I am asking you to do with modifying this guy, right? Okay, the model. The next thing that we need is to get the data from the user. Get the data from the user. Let me think about it. In my application, in the software that you create, did you notice that when I press the button, calculate, something should happen? Can you agree that your application, the graphical one, should extend JFrame, but also need to implement action list? Right? Okay, now, can you do all the programming to make, when I click here, call a particular method action perform?
Yes.
That is what I am asking with this thing, right? Okay, what do I need to do in the action perform method? The first thing, I need to read the data that I am assuming is on the text fields, right? Okay, the data that I am going to read from the text fields, they are strings. The first thing that you need to do is parse those strings to numbers. Now, in particular, the numbers that you are using are floating values, floats. All that explanation that I give you for the graphical user interface here translate in the fact that I am having these values in an array. Yeah, I am doing the console version. But for you, this array, these values, each of these values is one of the values that you parse from the input. Are you following? Okay, so can you agree with me that this block can be, should be in the action perform method? This one, the values. What I am doing in the next lines. One, I read the values. I am reading the values in an array because it's easy, right? You know how to work with arrays. The next thing that I need to do is to put that array inside of one of the objects that I need for working with the model. The model works with this guy, remember? So I need to create one of these guys. Input. The initialization. 1-4. What is this 1-4?
One dimension.
Remember that we have this 4-2 or 4-1. Okay, now I have 1-4. You're going to notice that these 4 elements, the one that I am going to use for input in the model. And I initialize with data, and that data cannot be the array. I need to encapsulate the array in something called a buffer. And the buffer is something that I can use as an input for this guy. The buffer, yeah, a data buffer. And that one is the one that receives as a parameter the array. I put this in 3 lines to show you kind of all the steps. But it's one line in which your int array is equal to this, and then the data is equal to new data buffer. Okay, you know the deal. All of that used to get the data from the application and encapsulate in the format that I need in order to use the model. A little bit of programming, but nothing new, nothing that you haven't done before. You need to put the data in a particular format. Clear? Okay. For my graphical application, this is something that you can put in the listener. For this main, I just put the lines there. This block, go to the listener. Now, you have the data. The next thing that you need to do. Do you remember this guy, the output? Can you call the method output from the model, but you didn't try the model here? Yeah, you load the model. Output. Help me, model output, and you pass one input. Yeah, I only have these 4 numbers of data. What is going to be the result here? It's an array. How many elements in that array?
One.
Tricky question, more than one. Remember the Iris model, right? How many outputs do we have?
3.
4 inputs, yes, 3 outputs.
Okay, yes.
Because you remember that we create this model with some number of middle nodes, but we have 4 here because 4 inputs, and at the end we put 3. And we put 3 because we create this probabilistic model, and basically we have 3 classes or 3 categories, and therefore 3 outputs. And if you are following my design, you have 3 outputs, and you use softmax, and you use likelihood. Therefore, we're playing with probabilities. Could you agree with me that you're going to have 3 outputs, and those outputs is going to be something kind of point, best case scenario 1? Output. Output is going to give you an array with those 3 numbers. Why that looks like something new? Because in the past, we never cared about the output. The only thing that we did with the output is pass to the evaluator. And to the evaluator, we pass the correct answer. So the evaluator is the one that from these 3, take 1 and compare that one with the correct output. But you have never worked with these 3 before directly. So 3. Okay, what do we need to do with those 3? Something that I put here just for you. If you do not believe me, you can try to print this guy. Obviously, this one is an object. And because it's an object, have a toString method, and therefore it's going to print something nice, and that something nice is going to be some square bracket with the 3 numbers that we're talking about. So you can print and notice 3 things. And you remember 3 probabilities. Good. What I am doing here.
Find the max.
Max number, max index.
I have 3 numbers, and you agree with me that that source code, programming 101, is looking for the maximum of those 3 guys. Why for the maximum? Because that should be the correct answer. Did you notice that the code makes sense because we know the architecture and we know what we are doing? Okay. Professor, really? I mean, we need to put this source code that looks like programming 101 in our application? What if I tell you that you can put together these 2? Because it makes sense, right? I mean, how many people is doing this? How many people really want the probabilities, and how many people really want the one that is the correct one? Model. Output. Model output give you the output, the 3 elements that are the output. Maybe what you want. You do not want the 3 values. You want the one that is the greater one. There is a method that returns that one. That method is going to do exactly the same thing that I am doing there with the for loop, in a better way even. It's going to give you the index of the maximum probability. Because to be honest, you do not need the value. What you need is the position of that value. Because remember, 3 numbers, and each of them correspond to 1 category. Category 0, 1, and 2, or whatever are the names that you want. Did you notice this array at the top? An array with the names in the data set. In the data set, we change for 0, 1, and 2. Remember that I mentioned you can use any number that you want, but a recommendation is to start with 0. And the only reason because you start with 0 is because that 0 is also the first element in an array, and therefore I can play with something like this. I am just printing, but you can do something else with this. Instead of printing in the console, you can put this value in a fancy space in your graphical application. Also, in the listener, in the action perform method. Makes sense. Good news, you can save this with predict, that is going to return 0, 1, or 2. Or if you do this, you calculate the index of the maximum value, and then you use that index for accessing the array. Clear. Easy, right? It's like, okay, you can transform this to something more important. Good. The thing that I want you to notice is the following. You can be doing the programming of the training, and you need to understand what is happening with the neural network. You need to know that you are doing neural networks. But when you pass to another group of developers the task of doing this graphical application that predicts the flower according with submeasures, the guys working on this application do not need to know that the neural network exists. For these guys, the only thing that they need to do is to load the model, call a method in the model, pass the data with this format, and it's going to give you an output, and the output you need to show to the user, period. What is the magic in the black box? These guys do not need to know. Moreover, this group here can improve the model, and here, the new model is on GitHub, get the new model. And the programming here with the application do not change at all. Clear? Okay, now, if you run the program, this is the part of the things, the source code that I have in the main, that now you know most of them should be in the method that is the listener. This is the output that you're going to have. 3 numbers, probabilities, category for this one is the number 0. So this should be the string in my array in the first position. Done. Good? Okay, this was easy, but now what if I want to work with something different? By the way, homework, not to submit, just for you to practice. Challenge yourself. Can you develop this application? I mean, everything that I described in the last 30 minutes is like, makes sense, and you can create an application following that instruction. If you can, good, we're moving forward. If not, you can use my office hours, emails. Again, it's not something that I am going to evaluate, but it's just something that you should be able to do. Like I describe a fancy application with listeners and putting together things that we already covered. Make sense? Okay, so your homework, your challenge. Next. I am sure that you are thinking like, no, that was easy. That was too simple. The student in 110 can do it. This one. You already have the model to identify the numbers. You already run that model and get these fancy results of the confusion metric and the accuracy and showing that your model is great. Can you create an application in which, as a user, I come here with the mouse, draw a number, and then the application tell me which is my number? What I am asking is, you have your model that was trained with some numbers from the data set, but now show me that it's working. Now, a big disadvantage that we have right now, your model is not convolutional. Your model is a simple, trivial neural network. So your model, the only thing that can do is to identify in one picture, one element. So that restriction implies that I cannot just write a number with several digits and expect the computer to identify all the digits. My restriction right now is the only thing that I can do in the square is to draw one number. And well, let's put a big space, right? Big space to draw something. And when I finish, prediction. For this application, I am going to show you the source code of the following. 3 elements in this application. 3 elements are going to be different classes, well, a group of classes. Number 1, I need this space to draw the number. And I am going to use the mouse because what I am going to use is a laptop, a computer, your computer for you to work. I need one space to draw. Second, I need to take a picture of this draw. And that picture needs to go to a 2D array. And hopefully you agree with me that from the picture to the 2D array, there are going to be some adjustments that I need to do. Adjustments, yes, because this picture here needs to be of a particular size. Which size? The same size of the pictures that I used to train the model. So the program can be running in a full screen or a small or whatever, but the size is not going to be exactly the size of the picture that I have, so I need to do some adjustment there. Moreover, it's a picture. Something that you are going to notice is we need to do some kind of fixing the colors. This point here looks very nice in the picture, but probably it's going to disappear in my array of 748 times 748. Right? So something that I want to do, something that I am going to show you is, when I take a picture of this, and I transform this to an array of the size of my numbers, what I have in the memory is the number that I put there in blue. The thing that I am going to show you here, black and blue, is what is on the memory, kind of the translation of my draw to the array that I am going to use to compare with my model. The thing in black is what I am using as an input. The draw, what I am using as an input, and below, the output. If I call output using your model with these numbers, what is going to be my output? Okay, we are understanding this, right? 10 numbers, if you call predict, it's going to tell you which one is the bigger one, but you have access to the 10 numbers. Right now, I am showing only one output. Do you think that you can show something like a conversation in which I told you, I think your number is the 2, but I could be wrong and maybe it's a 3 or a 4. You have that information, right? I mean, you know exactly what is my top prediction, but also you know what are the others. For the numbers, maybe it's not the same thing to do, but think about other data. It's like, I think this student is going to pass with A+, or maybe it could be C. But draw, show the input, apply the model. This program, it is going to look like the following. You are engineers, and I showed you this diagram before. Don't worry, I am going to show you also the source code. We're going to move to that. But before I show you the source code, and as a map of the things that are coming, this is the UML for my application, the one that I showed you before. Can you notice 3 classes in yellow? Those are the 3 classes that I am going to do. The classes in blue, the libraries that I'm going to use. In blue, the ones that are Java Swing, the ones that are graphics, the ones that are going to help me to do the application itself. In red, the only one that is related with machine learning, the neural net. Notice that I am just showing one there, but again, you are going to notice in the import several packages, because in order to use that class, there are several things inside that need other packages. But so far, my programming is going to be related with those things. From your expertise, did you notice that main is going to be the window? I am going to have an action listener. An action listener in the main. Why? I think I am going to draw the number, and in some point I need to select, calculate, run, or start working. That is going to be an action listener. In particular, I have a menu, an action listener. This guy is connected with the model. I think this guy is going to be loading the model, probably in the constructor, just as we did before. This guy, if you notice, is going to be using a draw area and is going to use an input image. Draw area, the space in which I can draw freely, the big one. Input image, my own class, is the class that has the image as an input for the neural net. That class, for sure, you notice the array, double, a 2D array of doubles, floating point numbers, whatever. I think this guy is important. Mouse listener. Why I have the mouse listener here and the mouse motion listener connected with this guy, draw area? You want to have a big area and you want to draw something? Hopefully you remember. That is mouse listener. You want to do something when I am moving, and also you want to be aware of click, release. One thing that we need to review, by the way, this guy is going to be a panel. You notice what's inside of a window. That guy is going to be also a panel. It was inside of the window. And the final result here is just going to be a label. You can make another panel, right? Label, panel, panel. This panel needs the mouse listener. I don't care about the mouse listener in the other spaces. This guy needs a 2D array. This guy is just a label that I can put some colors. And looks like that is the only thing that you need to create application. Seems easy. Obviously, the big architecture, the big picture, hopefully is easy because of the background that you have. There are some issues that we need to deal with. We're going to work with images. Something is going to happen with the images. We're going to deal with this idea of drawing something on the screen and transform that something to an image. It should be possible, right? You draw something on the screen and you create an image from that something. Yes. Let's see. 3 classes. Let's start with the first one, the main one. You're going to have the slides. You can play with this. You're going to have the source code. You can run and modify things and play. I am going to just be sure that we understand key elements in the source code, the ones that I put in the rectangles as usual. My assumption is that the things that are outside is something that you are familiar, that you have used before. If that is not the case, we can review it in office hours. But I assume that everything outside is clear for you, like here right now, the imports. There are graphical things. There are things related with the neural network model, and there are things related with exception files and images. Java AWT, Java Swing, and our library, Deep Learning for J, imports. Main, J-frame, action listener, something that was in the diagram before, nothing new. The only important thing here, did we notice what we have here? Draw area, one object from my class that is going to help me to draw things. J-label, the label in which I am going to print the result, the model that I need to load, the input image, the panel in which I am going to print what is in the array. This is exactly the 4 elements that we mentioned before when I explained what was in the picture, right? Those are my 4 global variables, my 4 attributes. Those are the 4 things that I need, right? And the only thing that I am going to do in the main is work with those guys. Working with those guys. This, the constructor. All the things that I didn't put inside of boxes, the goal is to create a very fancy, nice user interface. Did you notice that I put borders and text and accommodating a grid, la, 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 fancy things. The important things, 1, 2, 3, 4 things. What is happening in the constructor in those 4 lines? The 4 variables that I showed you before, we need to put a value on them. I am creating the objects from my classes, and the only one that is not one of my classes, the only one different, the model. Load the model using the library, the label, and the other two panels, you create the panels. And as you can notice, draw area was there before, label image was there before, create your panels. Everything else, put the things nice on the screen. Good. Okay, your variables, nice on the screen, perfect. What else? What else? Methods. Methods that are going to help me to do things. In particular, can you agree with me that the only work that this program needs to do, the only thing, is when the user finishes drawing, transform that draw into an image? It's the only important thing that this program needs to do. Get the draw and transform into an image. That work is inside of this method. Buffer, image. What? Yeah, read what you have on the screen and move that into an image. Okay, when you have that, the next thing that you're going to do, and you notice the for loops here, the colors, transform the image into an array of numbers. The 2D array that we need, right? Those two important things are done there. And what I want you to notice is there is nothing special here. Array, colors. According with the colors, is going to be a value, period. Or here you can make the picture gray, black and grays. Getting the image here. If you're familiar with Java graphics, do you remember these variable graphics? The G that you use to draw things on the screen. Remember, if you want to put something on the screen, you use this G. Remember the paint component method? And the paint component method receives as a parameter this graphic G. And then you can use G, dot, draw rectangle, draw circle, oval, etc. This G or graphics represent your space to work with graphical elements. And one method that you have there, one thing that you can do is literally ask for, give me what is on the screen inside of an object, and that object is going to be an object image or image buffer or image whatever representation. You can get the image from the graphics. And when you have the image, you can iterate every single pixel there. Really? Those two methods? But who is calling those two methods? The main should be familiar. The only important method here is the action perform, yes or no? You're going to do something. And then this action perform is going to be called, in my example, from a menu. But it could be a click in some place or whatever. When you call the action perform, I want you to notice 1, 2, 3 things that are happening. Looks familiar. Line number 1, draw area. Get image. Who is draw area? The area in which I am drawing. Get image. Yeah, you panel. I am drawing you, give me the image. You are going to be the one transforming graphic to something else, giving to me. Okay, when I have it, the two methods that I described before, my other panel is going to give me the image. Then my two methods are going to help me to transform whatever you give me in a buffer, whatever you give me in an array. And the array is what I need as an input. What is happening here? Model. Predict. Do we remember predict? We can use output if you want. image. Get features. Do we remember this get feature method? Okay, what is this level image? This one is an object. It's the object in which I am storing these pixels. Oh, where the pixels come from? The array, from calling my other method. This was the final result of getting the image, transforming to a buffer, transforming to an array. Now that array inside of a particular representation that I need in order to call the method in the model. Again, getting the data just like before, but this data needs to be processed in a different way, image to array, two methods for that, the previous one, and then the input, 748 pixels by 748 pixels to the model. And what I am going to get is the probabilities for each of the numbers or use the highest value. In this case, only the highest value, and the highest value is going to be here. The output is always an array, one element, set text into my string with the result. This is the place in which I get the prediction, and I show the prediction on the window. Other than that, complete the program. Clear the main. Okay, I am going to stop here. Please, I am going to publish the slides. You have access to the full program. Review the program. I am going to use some time next lecture to kind of catch on this, but this is something that you can use for your homework. For your homework, you can do something similar to the previous example with text data, or you can adventure and use images, but just remember, no convolutional way. Good, see you next week, thank you.